Kühlers. I work in the Google Berlin office, and I work as a solutions engineer on the Google Cloud Platform. So we're a small team in Bern with just 2 people working on the Google Cloud Platform. And I'm just going to talk today about how Hadoop can be a very good use case on the Google Cloud Platform, but also about the platform in general, because I know all of you have different workloads. So I just want to start with a bit of talking about Google infrastructure, because that's behind the whole platform, and that's my background as well. I used to be a network engineer, so don't drill down all on the Hadoop details with me, but you can drill down on building scalable networks. I used to do that for Google for 3 years. And then I'll go quickly through the products, really just like a 5-minute whirlwind tour through the products, and then I'm going to talk a bit about what we're doing in the Hadoop space. To start off, I always start off with a picture of a Google data center. We've been very secretive about our data centers for a long time. Then I think last year we decided, let's just be a bit more open and show what we're doing. We published really awesome photos of our data centers, so you can go on google.com/datacenters and you can see a lot about our data centers around the world, beautiful pictures showing basically how big the infrastructure is. And that's really the secret sauce about Google, that for the past 15 years we've been investing in this infrastructure, and we think there's no other infrastructure like this, and it's the most powerful cloud infrastructure on the planet. So on the network side, well, that comes next. Oh no. So basically another picture shows the whole scale of just one of our rooms of one of the data centers. And now with Google Cloud Platform we decided we want to open up that infrastructure for other developers. So it used to be, as a Google engineer, you have a lot more power than as a regular software engineer in another company. So now the vision behind that is everyone can be a Google software engineer. We can't hire all of them, but we would we would like to open up and help everyone build powerful full applications just like Google software engineers do. On the network side, where I come from, we've built an amazing global network. That's just a small part of it. That's the network we built between our data centers. And the special thing about this is we converted our network between the data centers starting a couple of years ago to an open flow network. What is an open flow network? Well, it's one of these software-defined network technologies, lots of people talking about it, where suddenly the routers don't have all the intelligence anymore. They don't need to decide, okay, I sent this packet to, I don't know, to Belgium, or I sent this packet to Finland. But what happens is we have a central located intelligence server, basically, which does all the computations, which has a view of the whole network, which in some cases even has a view of other input data, for example, what data transfers are coming up, etc., etc. And that way it can better make a decision on where to route the packets. So you can have a much higher usage of the network, and at the same time have less congestion in the network. So we started building it a couple of years ago. OpenFlow is an open standard by Stanford University, and last year we've publicized that we're using this, and it was a big surprise for people, because people thought, okay, this is very new technology, it's not ready for production yet we do run all our production traffic in between the data centers on it. What's not on this picture is our network, which is user-facing, which is where we connect to other ISPs, and that's basically all around the globe: Australia, Africa, South America, Asia. In all the continents we have points of presence to connect to other ISPs, to give to transfer data to other users. And the special thing there is we're trying to keep the quality on our network high, which means usually ISPs, when they have to send out data to other ISPs, they try to get rid of it as quickly as possible, because that way they can keep the load on their network low and keep the load on the other people's network high. We don't like that much, because the other people could have congestion. We know how much congestion, or that there's no congestion in our network. So we try to hand off the network traffic to the ISP of the end user as close to the end user as possible. And with this, we think we achieved the great speed you see when using Google products today. So Google Search served close to the user, other products not even served as close to the user, but the traffic is kept in our network as close to the user as possible. So that's just in our network. On the software side, Google has been publishing papers for a long time. GFS, MapReduce come out of Google. I don't have to tell anyone that, I think. Bigtable as one of the first NoSQL implementations, and now the biggest NoSQL implementations in the world. And then in 2008 we published a white paper about Dremel, and Dremel is our data analytics utility software, which we use for massive data crunching of billions of rows of data. We use it for our log data, let's say Gmail log data, we want to look into details. We use Dremel for that, and in 2012 we've publicized that as a product with Google BigQuery. Spanner and Colossus, just as the last things, these are our new database technology. Spanner is our new ad serving database, and Colossus is our new file system where we published white papers. This is just a view of what's to come in terms of external services. So the idea is to give other developers access to these services. Obviously with some of the products you already make use of those today. Google Cloud Platform, I think you all heard of these things. What we call Google Cloud Platform is in the infrastructure as a service and platform as a service area. Software as a service is also something Google does with Google Apps, but that's not part of Google Cloud Platform, just as a distinction. And what do we see as our usual workloads? Basically anything which has massive amount of users or massive amounts of data. So mobile gaming is big, especially games with a lot of users. Angry Birds on Chrome, and Facebook is running on Google App Engine, but also, big data workloads like Hadoop, just as some examples what can run on our platform. Okay, oops. Okay, this is just an overview of our products. We basically separate them into computing, storage, and extra services, and we have kind of the whole area of cloud services. It's a classical infrastructure as a service product of Google Compute Engine. App Engine is platform as a service, and then on the storage side we have a simple object store, relational database, NoSQL database, block devices, and then BigQuery, what I talked about in terms of data analysis. I just tell about 1 minute about all of the products. Google App Engine is a platform as a service where you can rapidly deploy web application or backends, and you can write them in 4 languages, Python, Java, PHP, and Go. And what you see here is the Google Cloud Playground, because we found out that for people to set up their development environment and try out the power of Google App Engine takes, let's say, an hour or 2, and many people don't want to go that step to just see what's possible. So with Google Cloud Playground, it's possible to just try out the platform as you go. You don't need to sign up. You can just go on the website and try it out. Open some samples from GitHub. Import your own samples from GitHub if you find someone else and run them. And it's all public, so you shouldn't store any private data there, but it's a quick way to get started. As an example there, I showed what we're doing in Code Labs from now on. It's building a meme generator in App Engine, and it takes about 2 to 3 hours in the Code Lab to do that. And then you have a web application and the amazing thing is it can scale automatically. It can scale to millions of users. You only write the application and we take care of all the doing the bits and scaling the applications. So it just runs, basically. And as one example, Snapchat, this photo sending app where messages self-destruct after 5 seconds, that started last year and now it's sending 200 million pictures a day. And they don't even have a full-time backend developer for that. They just run it on App Engine. More interesting on the Hadoop use case probably is Google Compute Engine. I'm just showing the console here. With most of our products, you have 3 ways of accessing them. You can use the web UI, you can use the command line utility, and you can use the API. And the cool thing with Google Compute Engine is the integration between these 3. So you can see we have a very cleaned up UI where you can try out setting up a VM. But then, once you set up your parameters, you can click here on equivalent REST or command line, and it shows you the command line or the REST call you have to do to get the exactly same thing, so which makes it much easier for you to automate building up lots of VMs. What we found out with, I'll go a bit more in detail about Compute Engine later, but basically we try not to copy, but we try to deliver some extra value in terms of speed and just make things a bit easier and deliver a great network as well. Google Cloud Storage, as I said, very simple object storage, save objects, get objects. What's a bit different there than with some others is we have read after write consistency. That means if you upload an object and then anywhere in the world 1 second later you download it, you already get the new version. It's not that you get served some stale version. So that's one distinction from cloud storage from similar products. Another one is that you use the Google network, and you can also use the Google caching infrastructure, which means the same infrastructure we use to serve YouTube videos, you can use with Google Cloud Storage if you have public objects. Google Cloud SQL, we have a relational database. It's MySQL in the cloud, basically, and you can get it in different sizes, different memory footprints. The amazing thing here is, like all other products, it's pay as you go. So with the MySQL, Cloud SQL, it's the same way. If you don't use the database, it shuts down automatically after a while, and then you don't get charged for it. Then if you do the next request for it, within seconds it gets up again, and you get charged again. So you only get charged by hours. So if you have a workload which doesn't run the whole day, for example, it's some office workload which is 9 to 5, you get only charged 9 to 5, basically. Cloud Datastore is our NoSQL database, and it's basically Google Bigtable as a service, and it's been used with Google App Engine for years. And this year we've decided to make it open for anyone. You don't have to use Google App Engine anymore to use the Datastore, but we've seen a lot of, it's a simple key value store. You build indices on the data you want, and it can scale infinitely as well. So that's the same infinite auto-scaling we call it the other services, and we see 4.5 trillion requests a month on Google Datastore at the moment. So it massively scales, and it usually just works. And then BigQuery is what I talked about briefly in our externalization of the Dremel service. And that's a massively distributed architecture which allows you to, in a column-based database, search massive data sets, billions of rows, and the answer always comes back within, let's say, under 10 seconds. So that's very useful if you have huge log data and you might not know yet what you want to do with it. You don't have to build an index on these because it actually queries it in real time. So if you have massive data sets, just upload them, and when you have some query, you just run it. And same as the other products, pay as you go. So you just pay per gigabyte of data queried and per gigabyte of data stored. So it's a much easier way to start than, let's say, building up any massive other, I don't know, the only thing which comes close to it is maybe in-memory databases, and that's a much higher investment. Just an example how it could all come together. Partner of us built this. I didn't put the details here. I think they put 4 billion rows of sample retail data in BigQuery, made with App Engine a visualization layer of this. They built it all with one engineer in 2 weeks, and most of the 2 weeks was actually creating the sample data, the fake data. And yeah, it shows that within a couple of seconds you can query this data set now and visualize it, and well, then they can went on and build a few more dashboards based on it. Okay, so how does this all work together with what you're here for, with Hadoop? Well, we've been doing MapReduce for years with the published white paper. On App Engine, we do run MapReduce as a service. It's an open source project which we built on top of App Engine. So you can look at the code, you can tweak the code, and it's basically simple, managed, and scalable. And you can integrate it in App Engine very easily. The only caveat is it's still experimental. So you might have to actually tweak the code or look at it, and there's no SLA on the service itself because it's open source, so that's the caveat with that. So we're mostly focusing on Hadoop on Compute Engine, and why should you run it on Compute Engine and not on another cloud? We think the speed, the scale we can do, and the speed we can do. What we hear from people who try it out, and I just encourage you to try it out, faster boot times, you get consistent I/O performance on both type of disks. So we have a scratch disk, which is basically the disk which is directly attached to the VM, and we have a network disk, a persistent disk. And with both of them, you get high consistent I/O performance. Maybe on the peak it's not as high as with some competitors, but at least if you run it once, you know this is the speed you will get next time. Same consistently fast network intra-cluster. You shouldn't see any noisy neighbor problems just because someone else is running workloads in the same cluster. And then for the external network, not so important with Hadoop, you also take advantage of the Google network I've mentioned. Another thing which might be interesting, depending on how you run your workload, is sub-hour billing. So if you run a workload for 10 minutes, you only get billed for 10 minutes. We start at 10 minutes and then it's minute by minute after. And especially with Hadoop, it's about the high memory options, and they're quite competitively priced. So if you compare pricing a bit, that's something that you might also notice is maybe a little bit better. Now, how fast is it exactly? And I'm gonna try this. No, that draws. Then I'll put this string. So we've run the terror sort with our colleagues from MapReduce last year. Let me see. And so this is a terror sort we built on 1,000 cores in Google Compute Engine, 1,000 nodes with 4 cores each in Google Compute Engine. And once the cluster is set up, this is the MapReduce console. The whole thing took about 55 seconds to finish. So you can see most, well, you could have seen if it actually loaded. Most of it is actually the reduce job. Some was thinking this is only 20 seconds long. Let's see. Okay. I think I might have to skip down. Last try. Had a bit of issues with that video we did earlier. Yep. So you can see the map job actually completes within a few seconds on the 1,000 nodes, and then it's the rest of the time is the reduce job running. The whole finish in 55 seconds. And what's the amazing thing about this is the setup time. They basically could pull this together in a day. The whole setup, etc., you can pull it together in much less now. You've done it once. And you see it's, and the cost was also different. The previous record, shouldn't be, apparently. I think so. Hold on. Connected to the wrong Wi-Fi. Okay, so basically the previous record was set up by Yahoo by building up a physical cluster of nodes, and it took them months. It came at a cost of nearly 6 million, and they needed 11,000 cores to run the Terasol in 62 seconds. And then for MapReduce, doing it on Compute Engine, they ran the workload with 1,000 nodes, so 4,000 cores, sorry. And that came at the cost of $582 an hour. That's also what they paid at the time. Now we moved to sub-hour billing, they would pay closer to less than $100 for the whole workload. So that's really amazing that if you have a big workload and you just want to try something out, it's a very simple way to get started and a very simple way of running your big computations if they're like one-time tasks. Back. Okay. Cdiscount.com is in France is the biggest online retailer for electronics. They wanted to do prediction, customer sentiment analysis. What should we recommend to the customer who bought this last? And they're running this in Hadoop on Google Cloud Platform, and they ran this against other cloud competitors, and they ran this against their on-premise warehouse, and they decided to do this on Google Compute Engine, basically because it was the fastest solution for them. Okay. Now what's the easiest way to get started? So either we offer, you start with a partner like MapReduce, they offer a service, so they can, you run a distribution on Google Compute Engine, or you can build up just Apache Hadoop on Compute Engine. We've written two solution papers, one on just how to manage Hadoop clusters, and this goes a bit into details. What kind of disk should you use? Should you use the network disk, or should you use the scratch disk, and for what reason? What do you need to take care of in terms of DNS and whatever? And maybe little caveats you would otherwise run into. And then we have the same for whole configuration of Hadoop-pig. And we have GitHub repositories of basically sample scripts where you can run sample clusters and build them up in, I took about half an hour yesterday.